Here is part 2 on the idea that the acceleration of an object is parallel to the net force acting on the object. Here I'm going to show you how to find the net force on an object using the so-called parallelogram method for adding vectors. It's equivalent to the head-to-tail method I showed in the previous video, but just a different way of visualizing it. So here again is that same free body diagram for some object with 3 forces acting on it. And this time we're going to find the net force by adding these 3 two at a time. So if I pick off F1 and F2 first and sort of redraw over here the FBD with just F1 and F2, I picked off those 2. I want to have them tail to tail like this, just as they already are for a free body diagram, tail to tail, and then use these 2 vectors as 2 sides of a parallelogram. We're going to draw in the rest of the parallelogram. So let's see. Since this vector goes over 4 and up 4, then down here I need a side that goes over 4 and up 4. There's one side of the parallelogram, and then here I connect from here to there to get the other side. Good. And now I've got all 4 sides of the parallelogram. The sum of these 2 vectors is then just represented as the diagonal from this vertex here where they meet to the opposite vertex there. Drawing in that vector, that diagonal, that represents the sum of F1 plus F2. I'm going to call it F12 for short, the sum of F1 and F2. Now that we have that, I can then add in this 3rd vector over here, F3. So we redraw a diagram with now F12 redrawn over here. I see that it goes over 6 and down 1. 3, 4, 5, 6. Yep, over 6 and down 1. Oh, I messed it up. Over 6 and down 1. That's okay. And then I'm going to add in F3 over here, which goes over 3 and up 2. Over 3 and up 2. So there is F3, and here is F12, the sum of F1 and F2. And now those are going to become the legs of, or 2 sides of a parallelogram. So I've got to draw a side that goes over 3 and up 2, starting from here. So over 3 and up 2 goes to there. This will be a narrow parallelogram. And then over 6 and down 1. There. Okay, so this skinny sort of flattened parallelogram here can be used to find the sum of this vector plus that vector. It again goes from this vertex to the opposite vertex. So that I'll call F1, 2, 3 right there, which represents the sum of all 3 of those vectors, F1, F2, and F3. We see that it goes over 3 and up 1. And if you check against the previous video, you'll verify that this is the same result that we got from the head-to-tail method. So try one out on your own. Here is an example. Same free body diagram from the last video. 4 vectors this time. I want you to add them using the parallelogram method, taking them 2 at a time. So start by adding F1 and F2. Then take that result and add to it F3, then take that result and add to it F4. So this will be a 3-stage process using 2 vectors at a time with the parallelogram method. You'll need some graph paper for this. Go ahead and pause the video and perform those additions. Ready? Okay, here's the results. I draw just in F1 and F2, make a parallelogram, and I get this vector as the sum of F1 plus F2. I'm going to call that F12. Now if I add to that F3 in a new diagram, here's that F12. I'm going to add to it the F3 over here. and make those two the sides of a parallelogram, and then this diagonal here is the sum of those. That's F1, 2, 3 right there. I'm going to take that in green and add to it F4 over here. So here's the F1, 2, 3 all added together. Here's the F4 added to it. That makes another parallelogram and drawing the diagonal. And that right there, F1, 2, 3, 4, that's the sum of all four of those vectors. And you can check that that is also in agreement with what we came up with using the head-to-tail method. So you get the same result. I suppose to kind of compare our two approaches here, our two graphical methods for adding vectors, first the head-to-tail method. That's really best if you have 3 or more vectors to add, because you can make a chain of vectors that is an unlimited length, add in as many vectors as you want, and you get the total result, the total sum of those 3 or more vectors. This parallelogram method here, it's quickest if you have just 2 vectors to add. If you have just 2 vectors, this is best. You'll also find that to do the head-to-tail method, you pretty much need some graph paper to do it accurately. However, the parallelogram method, that can often be done freehand, even without graph paper, so that makes this more convenient at times as well.